Welcome back, ChemStars, to Chapter 3 video number 4, 3.31, Distinguishing Among Atoms. Get out your periodic table now! Actually do it. You need a periodic table. I'm going to be flipping between my screens to show you a periodic table, so make sure you have that handy with you. I handed you one earlier in the year. There's one on the back, I think, of the note packet and the homework packet, so make sure you have one available, please. Okay, so let's go through our I can statement first. So after this video, you will be able to use the periodic table to determine the atomic number, atomic mass, mass number, and number of protons, electrons, and neutrons in specific isotopes of elements. A lot of these should be reviewed from physical science class, but also isotopes might be new to you. So we also will be working on applying mathematical models to the problem. And here are our key vocab words: proton, neutron, electron. Oops, neutron shouldn't be there twice, sorry. New vocab I showed you last video was atomic mass unit, and then isotope. That's what we really want to focus in on this video. Okay, so let's see here. Number 1, atomic number. Ooh, that was an interesting effect. Let's try a different pen then. Atomic number. Every atom has protons and neutrons in the nucleus with electrons orbiting the nucleus. You learned that already. B, all atoms of the same element have the same number of protons. You learned that already. The new thing is the atomic number is the number of protons. So we're going to practice using our periodic table. So let's find hydrogen. Go to your periodic table. We're going to look for hydrogen. Hydrogen is right here. And let's look at our key. The atomic number is in the top left corner. So hydrogen's atomic number is 1. So on your notes, we're going to say hydrogen atomic number is 1. That means there is 1 proton. I want you to try helium on your own. So pause the video, get out your periodic table, and go to helium. Thank you for pausing, those of you who actually did. Here is helium. Top right corner, atomic number 2. So there are 2 protons in the nucleus. Helium has 2 protons. Now let's look for carbon, gold, and uranium. Pause the video, look those up, and we'll come back in a moment. Good. So did you get that carbon has 6 protons, gold has 79 protons, and uranium has 92 protons in the nucleus? If so, you're using your periodic table correctly. I'm just going to highlight where you can find those on the periodic table. Okay. So let's get back here. So let's look at what the mass number means. So we looked at atomic number, that is protons in the nucleus, and we're going to compare that with the mass number. The mass number is the total number of things, of particles in the nucleus. Remember back to our other notes, the mass number is going to be equal to the protons plus the neutrons. So mass number is protons plus neutrons. This is our basic algebra equation we can use to solve for any of those 3 things. So if you want to figure out how many neutrons there are, you can take the mass number and subtract protons. Let's look at an example to help you understand this. Let's look at gold that has a mass number of 197. So what does that mean? The name is gold. So if you go to your periodic table and zoom in on gold, the atomic number is 97. And here at the bottom, it says its mass is 196.967. Don't worry about why that's a decimal right now, but you can see it's really close to 197. So atomic number is 79. That means there's 79 protons in the nucleus. So for it to be gold, there has to be 79 protons in the nucleus. So 79 protons in the nucleus. But then we have that new thing, the mass number. So that 197 means there's 197 things in the nucleus. So how many neutrons are there? Well, we know that there's 179 total things, and that 79 of those are protons. So there must be some unknown number of neutrons. So how would we get that question mark by itself? Yep, we'd subtract 79 from each side. So how many neutrons are there in here? So there are going to be 100 neutrons. Good. Let's go through and try some more practice. Okay, so what if we have 33 protons and 41 neutrons? We got to go to our periodic table and find atomic number 33. So atomic number 33, let's see, goes in order here. That is arsenic. Arsenic, atomic number 33. So the symbol for arsenic is AS. Just make a note for yourself. This is arsenic. AS. Let's look at our example from above. I put the total number of things on top. I put atomic number on the bottom. Okay, so we know there's 33. But what is the atomic number on this one? Or the atomic number is 33. What's the atomic mass? There's 33 protons and 41 neutrons in the nucleus. So how many total things are there? Well, 33 plus 41. So that is going to be 70. So 3 plus 4 is 7. 3 plus 1 is 4. There are 74 things. So there's arsenic, 74. I can write that out long form. Arsenic, 74. When I say arsenic, everybody knows it has to be 33 protons. That's what makes it arsenic. But the 74, that's telling me which type of isotope that is. Okay, let's see. Mass number 244, that's a pretty heavy atom. Neutrons 150. If you go to your periodic table, can you look up what that actually is? No, we need some more information before we can actually find out the element. So we have to do a little bit of work. So I know that the mass number is 244, and that's equal to protons plus neutrons, which is 150. So how many protons are there? So 150 minus 244. Do some quick mental math. You should see, okay, let's see. 150 to 244. So 50 plus 44. That should be 94 protons. Now we can go to our periodic table. And what is atomic number 94? Aha! Plutonium. Oh, it's out of frame. Sorry, guys. Plutonium. So let's go back. Now that we've discovered that this is plutonium, so we know that's plutonium, atomic number 94, and how many total things are in the nucleus? What is the mass number? They told us 244. I'm running out of room right here. I'll kind of put it on the side. So let's write it out long form. This would be plutonium 244. Okay, now let's do it visually. So here's the first example. The clear ones are protons. So 2 protons, 1, 2, 2 neutrons. I know that protons plus neutrons equals my mass number. So the mass number is 4. What element is this? I want you to pause the video, use your periodic table, and come back. Good job, you're correct. It is helium. You figured that out because you went to your periodic table, you found atomic number 2, which was helium, and then you counted up how many total things there are. Well, there are 4 total things, so it's helium. It is helium-4. That is an isotope of helium. Try the next one. Pause, then come back and check your work. Very well done. If you found that this is lithium-7, you are correct. Okay, let's flip the page. So now let's figure out what is the isotope actually, because I've been writing some isotope notations and haven't exactly told you what the isotope is. So the main point that Dalton was wrong about was that not all atoms of the same element are same physically or chemically. They got the same number of protons, but they have a different number of neutrons. So they got the same atomic number, same protons, but different mass numbers. Neutrons are different. So for example, there are 3 forms of hydrogen. We have hydrogen 1, that means there's 1 thing in the nucleus. Hydrogen 2 with 2 things in the nucleus, and hydrogen 3 with 3 total things in the nucleus. So let's fill that in. So hydrogen 1, there's a mass of 1. Hydrogen 2, mass of 2. Hydrogen 3, mass of 3. But since these all are hydrogen, we know they all must have the same atomic number. We know they all must have the same number of protons, which from our periodic table is 1. Okay, so they all have 1 proton, 1 proton, 1 proton. That is what makes them hydrogen. So when I'm writing out the isotope symbols, we know this is the same, this is the same, this is the same. Like I said, though, they have different masses. So hydrogen 1 has an atomic or mass number of 1, hydrogen 2 has a mass number of 2, hydrogen 3 has a mass number of 3. So what is different about these? They all have that single proton, single proton, single proton. But hydrogen 2 has 2 total things. What is the only other thing it could be? Must be 1 neutron. So hydrogen 2 has 1 proton, 1 neutron for 2 total things in the nucleus. How many neutrons does hydrogen 1 have? None. There is just 1 proton. So use your good critical thinking skills. Hydrogen 3 has 3 things in the nucleus. One of them has to be a proton. That means we've got to have 2 neutrons. Okay. We know also that neutrons are neutral. We know that protons have a positive charge. And we know that the atom is neutral itself. So for every positive charge, I've got to have an electron. So 1 proton, 1 electron. 1 proton, 1 electron. 1 proton, 1 electron. So each atom of hydrogen is going to have 1 electron, and that's to balance out the charge. So protons and electrons are the same, but the neutrons can change. So take a look at those 3 forms of hydrogen. All hydrogen, but a little bit different on what's going on inside of the nucleus. Okay, let's scroll down and try some practice. I'm going to model the first one, and then I want you to go ahead and try the next one. So let's break down 2 different isotopes of oxygen. So that means it's the same element with different numbers of neutrons. So oxygen, check your periodic table. You're correct. Oxygen has 8 protons. That is what makes it oxygen. Here we're told we have oxygen 16. So the mass is 16. So there's 16 things in the nucleus. 8 of those are protons. What is the missing neutron number? 8. Because 8 plus 8 is 16. Let's compare that to oxygen 17. There are 17 total things in the nucleus. 8 of those are protons. How many of them must be neutrons? 9. Because 8 plus 9 is 17. So are these 2 isotopes? Yes. Same element, same number of protons, but different number of neutrons, and they have a different, I'm going to abbreviate here, mass number. So yes, those are isotopes. I want you to pause the video and fill in the example for iron 56 and cobalt 56 and tell me, are they isotopes and why? Make sure you explain. Good. So I'm hoping that you found that they have different number of protons because they're literally different elements, so there's no way they could be isotopes. Because our definition, isotopes are the same element, so these can't be isotopes. They do have the same mass number, but that doesn't mean anything because there's different numbers of protons in the nucleus. Okay. Let's flip to your next page. So this is a whole bunch of practice for you. We're not going to go through the whole thing, but I'm going to get you set up and get you started in the next couple of minutes. So let's look at what you can fill out. You'll definitely see something like this on your test probably. So we're looking for the element name. So for example, we have hydrogen 1. The symbol. We want to actually use the isotope symbol. So we're going to have hydrogen with 1 proton, and we need to know the mass. Well, this is the mass number right here. So it's always the name dash the mass number. So we have hydrogen 1. Atomic number 1. Protons 1. Atomic number in protons must also be the same. We've shown you also that protons right now will always equal electrons to keep the atom neutral. So hydrogen, because it's hydrogen, there's 1 proton. That means that there's also 1 electron. The mass number is going to be 1. They told us that. And remember, the mass number is protons plus neutrons. So we have 1 proton, and there's 1 total thing in the nucleus. So how many neutrons are there for this example? 0. This last part, is it the most common isotope? We're going to do a real quick check on that. So this is new, but if you look at the periodic table, let me move my video frame a little bit, and we look at what hydrogen has. I have to erase this so you can see it. The weighted average is printed on the periodic table. Just for right now, I want you to take that number and round it to the nearest whole number. So we've got 1.008. Round to the nearest whole, that equals 1. And that is the most common isotope. So if we go back really quickly before the video ends.